this lesson, we are going to continue with the first principle, where we are going to see how we use the first principle to solve functions that are of the form x to the power n, okay, which we term as what's the power rule. So we'll use the first principle to solve functions that are of this form. Let's first state the first principle. It says that the y derivative, the first derivative of the function is going to be limit as our h approaching 0 of the function at x plus h minus the function at x, okay, all over h. Okay. Now, by our function is of the form x plus n, x to the power n. So we are going to evaluate the function at x to the power n minus the function at x all over h. So this is going to be our limit as h approaching 0 of the function at what? X plus n. So we are having what? X plus h to the power n minus what? X to the power n. All this over what? Our h. Okay. Now let's see how this function, the form of this function, how can we now break this? Let's take, for example, when you are being given a to the power 3 minus b to the power 3, how can we expand this? This can be expanded by when we take a minus b, which is going to be one of the terms, then we are now going to take what? Take 1 out of this. The highest power here is 3. We are taking 1. So it means that we are left with 2. A now begins with the highest power. Then B will now start with what? The least power, which will be 0. So B is with 0. Plus, now A now start decreasing to meet the least power, whilst the B increases to meet the highest power. But our highest power over here is 2. So when we decrease this by 1, we have a to the power 1. Then b also takes the power 1. Then we add it to the third one. Now here, a now meets its least point, which is 0. And then b also meets its highest point, 2. By that, we now have a minus b, a squared, plus our ab plus some b squared here. So this is now the expansion. Let's also take example, a to the power 4 minus b to the power 4. Now, the same way, we are first going to take 1 out of them, then 1 out of this. So it means that the highest that we are going to be left with is going to be what? 3. So A now takes the highest one, 3, and then B takes the least, which is 0. Then this is 0, plus A now start decreasing. A, the powers of A decreases by 1, so this is 2, while B now climbs up, where B now gets 1. Plus, we also have what? A also gets to 1, where B goes to 2, plus, now our A over here will now get to what? Our A over here now get to its least, where B also gets to its highest, which is 3. Okay, so what is that also going to give us? We are going to get A minus B. This simplified, we are getting on A to the power 3. Then this will now be what? Plus our A squared B. This is also plus power A B squared plus our B to the power 3. So this can be the simplification of this. So we are going to use this same explanation here to expand this, where our x plus h to the power n, x plus h will just be our a, and then x over here will just be our b. Okay. This is going to show that we have, this is just going to show that we have our limits as h approaches 0. Okay. Over here, we know that it's all O divided by h. So the first term is what? X plus h. We take it out, minus x. This is to the, okay, this is x plus h. Okay. Then the whole now, we now take it. Now here, we have what? What is the highest power that we are having over here? The highest power is n. So when we take 1 out of it, we are having what? N minus 1, which is now what? Our highest power. So the first term is taking the highest power, which is x plus h, n minus 1. Where the second term is taking the least, which is what? X to the power 0. We add it to the second, which is going to be x plus h, And then here now becomes what? Our n minus 2, where here becomes what? X to the power 1. Okay. So we continue to sum n terms. Let's add the third term. But then let's take away this one so that we can get some space over there. Okay. So what will be our next term? This is n minus 2. So we are now going to get x plus h, n minus 3, and here minus 3, multiplying x. This is climbing, so x to the power 2, all the way up to. So now what will be the least term of this one? The least term of the first one is going to be what? 0. So it means that here we are going to x to the power x plus h to the power 0. Where here now goes to what? The highest term. But the highest term over here is what? N minus 1. So we are getting what? X to the power n minus 1. Okay. Now, as we have over here, we first have here to be x plus h minus x. This can take away this. So we are just now left with limit as our h approaching 0 of 1 over h. We have only h over here. Now the whole term is now what? X plus h n minus 1. This is what? 1. So we leave that. Then we now come to x plus h. Then here is what? N minus 2 multiplying our x plus our x plus h over here. But here it is what? N minus 3 multiplying x to the power 2. All the way up to the last term. This now becomes what? 1. So we have x to the power n minus 1. From there, we know that this h can also cancel this h. Then we now evaluate the function where h approaching 0. So wherever we see h, we put 0 over there. So we are having limit as our h approaching 0 of x plus 0 n minus 1 plus x plus 0 n minus 2 multiplying x plus x plus 0 n minus 3 multiplying x to the power 2 all the way up to the last one n minus 1. When we simplify this further, we are going to be left with our x all to the power n minus 1 plus here to this is 0. So we are just left with x n minus 2 multiplying x. This is also plus x. Okay, so here we are just having x to the power what? N minus 3. N minus 3 multiplying x to the power 2. All the way up to the last term, x n minus 1. Okay, now as we have this, what can we deduce? Let's consider laws of indices. When we have a to the power 3 multiplying another a to the power 4, this is the same as a3 plus 4. The same way, when you have 2 to the power 2 plus 2 to the power 6 is the same as 2 to the power 2 plus 6. Okay, so the same way over here, we first have the first term to be x n minus 1. Now over here, we have an invisible one here. So we are going to get n minus 2 plus 1. So it means here we are having what? X n minus 2 plus 1, which is going to give us what? X n minus 1. Where we have x n minus 1 over here. Plus the same way, adding 2 to what? Minus 3, which is 1. So x n minus 1. All the way up to the last one, x n minus 1. Okay. Now that we have all this, how many times of this do we have? We first took it to what? To the power n. So it means we have what? N times. Since we have n times, we can represent all this to be n multiplying x to the power n minus 1. Which now gives us what? Our power rule. Okay. So follow me as the next video we'll talk about how to still use the first principle to solve or to find out the quotient rule. Thank you.